Guys, today we are going to introduce this problem. Is problem B in division 1, alright? So let's begin. As always, we are going to explain this problem by introduce the example here. So we are going to use the second example, right? So let's begin. In the input, we are going to have a tree here, right? The first number is the number of nodes in the tree. So we are going to have 5 nodes in the tree. 1, 2, 3, 4, 5, right? And the first column of those nodes is the parent of a node, right? So the first node parent is 0 because it doesn't have any parent. And for the second node, its parent is the first node, right? And for the third node, its parent is the second node, right? And for the fourth node, its parent is the third node, right? And for the fifth node, its parent is the second node, right? So that's the structure of the tree. And then for each node, there is a counter. So for the first node, its counter is 1. And for the second node, its counter is 3, etc. Right? So what are we going to do is to assign a value to each of the nodes, like the output here, right? So we assign So we assign 2 to the first node, assign 3 to the second node, 2 to the third node, 1 to the fourth node, and 2 for the fifth node, right? Why do we assign these values? Because we had to satisfy this counter condition, right? What is the counter condition? That means the subtree, there are 1 numbers that are less than current value in the subtree of this node, right? So for example, for the first node, we can find only this number is less than 2, right? So the counter is 1 here, right? That is why the counter condition is satisfied for the first node. And we move on. For this node, its subtree is this one, right? So we have 2 less than 3, 2 less than 3, and 1 less than 3. So we found 3 numbers. So the counter is 3, right? And for this node, there is only 1 number less than 2, right? So the counter is 1. And for this node, there is no number less than 1 because it has no children, right? So the counter is 0 here. Also for this node, right? So we only need to find one feasible solution to satisfy the counter condition here, right? So if we cannot find any solutions suitable for this condition, we output no here, right? In other cases, we output yes and output the value assignments, right? So let's introduce the solution here. So we are going to use deep first search to solve this problem recursively. So let's take a look at the solution first, right? So we are going to solve each node, right? Solve means we are going to assign a we are going to assign a feasible value to a node and its subtrees, right? So first, we are going to solve the root node, right? We are going to solve this one. So the p equals to 1, right? Index 1. So we are going to choose a value for this node. So which value are we going to choose? So before we do that, we are going to um, give us a task that we are going to assign 1 to n to this node, right? We're only going to use distinct numbers to assign to those nodes, right? So what numbers can we choose from? We can choose 1, 2, 3, 4, 5, right? These are the only numbers we can choose from. So in this case, which value are we going to choose? Because the counter here is 1, right? So there is one number less than current number in its subtrees. So what are we going to choose here? Obviously, we are going to choose 2, right? Why? Because if we choose 2 here, then these 4 nodes will choose from 1, 3, 4, 5, right? And among these 4 numbers, there is only one number less than 2. So we can be sure that this counter is satisfied, right? So we can choose 2 for this node and move on. So this is the example output. We are going to delete it for now and find our own solution here, right? Which is 2. And then let's find a value for the second because we are going to solve the same problem for all of its children, right? So we solve this one first. So which value are we going to choose? So we have 4 options. We already chose 2, right? Now we can choose 1, 3, 4, 5. So which one do we choose? In the same way, we are going to choose the third biggest, the third smallest number, right? So because there are there are 3 numbers less than this value, so we are going to choose the fourth number here, right? Which is 5, right? So that the rest of nodes can only choose from 1, 3, 4, right? Which all of them are smaller than 5, which makes our counter 3 validated, right? Satisfied, right? So we choose a 5 here, and then we move on, solve its child, which is this node, right? So now we have 1, 3, 4 to choose from. Which one do we choose? We choose 3 because 3 is the second smallest number here, and its sub trees can only choose from 1 and 5, or 1 and 4, right? And we are going to move on. So this guy has a counter of 0, so we are going to choose the smallest, right? Which is 1 here. So we choose 1 here. And we trace back to this guy. and solve its second child, which is this one, right? Which number can we choose? The only option is 5 now, right? Because 1 is already 1 second. The only option is 4 now, right? Because 5 is chosen, 3 is chosen, 2 is chosen, 1 is chosen. So the only option is 4. So we choose 4 here, right? So let's re-evaluate our answer. Um, for this node, there are 1 node less than 2. Correct, right? For this node, there is 3 node less than 5. Correct. For this node, there is 1 node less than 3. Correct, right? For these two nodes, there is no number less than it, obviously, right? So in this way, we solve this problem. So one thing need to mention is that we need to make sure that how to find out the condition where there is no such trees, no such assignments satisfy the counter number. When does this happen? So there are two possibilities, right? So the first possibility is that um, when we choose a value for a certain node, for example, let's say we have, in this case, we have 1, 2 to choose from. But this guy here says that we need to have 5 numbers less than current number. So we only have 2 options. So we cannot find the 6th number, right? For as the value of current node, right? That's where the counter condition can never be satisfied, right? And the second condition that we cannot find a feasible solution is that when we trace back, we find out that the total number of nodes for this in this node's subtree is less than the counter, right? Let's say the counter says I want 5 nodes smaller than the current node's weight. Actually, it only has 3 nodes, right? But it asks for 5 nodes. So this kind of condition can never be satisfied. So we need to add a logic to make sure of that. So I guess that's it. Thank you for watching. You can find the source code in my video description. Alright. The source code is quite simple. Again, thank you for watching. Hope that helps. See you next time.